Assignment 16, for the next section, I'm going to split this up into a couple of days. The first day will be all about factoring quadratic equations. And then the next day we'll talk about actually applying that. So this is solving quadratic equations by factoring. Okay, so before we can actually solve these quadratic equations by factoring, so we'll call this day 1. Today we're really just going to learn how to factor quadratic equations. So our essential question right now, before we can actually solve these by factoring, we need to remember how to factor them. And I am guessing that all of you have done this in the past, but very few of you are really good at it. So this is going to be something that you're going to struggle with. It's going to be hard. It's going to take a lot of work. And it's going to take a lot of time. And it's going to take a lot of practice. And stick with it. And all of a sudden, you'll just start seeing it. Like, it'll actually happen for you. It doesn't go away. So you're going to get to college, and they're going to expect you to be able to factor. And I actually remember in my college calculus class, that was where, it really came down to the people that could do their calculus were the people that knew their algebra and the people that could factor. Okay, so enough about that. Trust me, you need to work hard at it, and you all are capable of doing this well. So today's question is, how do you factor quadratic expressions? So we won't even get to the part about solving, so we don't need equations yet. Okay, I'm just going to keep these as expressions for now. So we can focus on the factoring. All right, so as we have reviewed, whenever you are multiplying binomials, you end up with a trinomial. Okay, so thinking back to that worksheet that I gave you and our last assignment, right? So whenever we multiplied these binomials, we ended up with a trinomial. So today I'm mostly going to talk about taking those trinomials, so taking something like this and getting back to where we have two binomials. Okay, I'm going to veer away from that a little bit when I talk about just factoring out a common factor from everything, and when I talk about factor by grouping. I like to think about factoring as going through kind of a checklist. So I'm going to call these your factoring friends. And every time that you need to factor, I want you to go down the list. Okay? So these are going to be our factoring. They're basically factoring methods, but I'm going to call them our factoring friends. Okay, so our first friend, the one that you're always going to go to first, I call that friend the greatest common monomial, or the greatest common factor. And to abbreviate it, we'll call it GCM. So we don't always have to say greatest common monomial. Okay, so this one, as an example, would be if you wanted to factor 3x squared. Let's do a y squared as well. Why not? Plus 6xy plus, well, let's do a minus. Throw a negative in there. Minus 21. Okay, we want to factor this. So what you want to think about is, what is the greatest common monomial factor of all three terms, right? Notice that there are three terms. Terms are divided up between addition or subtraction. Okay, so I have three terms. This is a term, this is a term, this is a term. Okay, and they all have a common monomial, so one term that I can factor out. Okay, so I see that they all have a 3 in common. Okay, and that's pretty much all they have. So I'm going to factor out a 3, and you can think of this as like reverse distributive property. So if I take a 3 out of each term, what's left? Well, 3 times what will give you your first term? X squared, y squared. And 3 times what will give you your second term? Well, 2xy. And 3 times what will give you your last term? -7. Okay, so that is factoring using the greatest common monomial. You always, anytime that you are given something to factor, the first person that you go to, your first friend, is greatest common monomial, because if you can factor out that greatest common factor first, or that greatest common term first, then it's going to make the rest of this really easy to deal with, okay? Not in this situation, but in most situations. All right, so the next one. The next friend, now these are special product patterns. So the next friend is called a difference of 2 squares. Okay, so an example of this. You would see something that looks like this. For example, x squared minus 36. Okay, so you need to ask yourself, first of all, is this a perfect square? So is the first term a perfect square? It is. It's x squared, right? So I'll write it as x squared. So basically, can I write this as 2 perfect squares? And can I write 36 as a perfect square? Yes, it's 6 squared. And is there a difference sign between them? Yes. So this is a difference of 2 squares. So when I factor this, all I do is I take the square root of my first term, and I put that in each binomial as my first terms. I take the square root of my second term, and I put that as my last terms. And here's where it gets a little tricky. You have to use a sum and difference pattern. So a difference of 2 squares results in a sum and difference pattern. Now here's where your knowledge of FOIL really comes in handy. Because notice on this, when I multiply these 2 binomials together, I am not getting a trinomial, right? There's no middle term. There's no term with just an x. And here's why. My inners, which give me 6x, and my outers, which give me -6x, basically cancel out and give me 0. So there is no middle term, which is why we use the sum and difference pattern to get rid of that middle term. Right? So anytime you have a binomial, first term, last term are both perfect squares, and there's a difference between them, then the result is this thing called a sum and difference pattern. Okay? Basically, they both have the exact same numbers. Both binomials have the exact same terms. The only difference is they're going to have a positive and a negative sign. Okay, so if you were given something to factor, the first friend you'd go to is greatest common monomial. Well, like for example, this one, I don't see a greatest common factor in these 2 terms. So I couldn't do that. Okay, so then I go to difference of 2 squares, and this one's going to be beyond obvious. It's going to be a binomial. It's going to have a subtraction sign. It's going to have 2 perfect squares. Okay, if it's not a difference of 2 squares, because maybe it's not a binomial, then you'll go to your third friend. Your third friend is called the perfect square trinomial. This is another special pattern to recognize. Okay, so an example of this might be x squared plus 10x plus 25. Actually, let's put a subtraction sign here, just to give you a negative example. It works both ways. Okay. So on this one, I notice that my first term is a perfect square, right? It's x squared. I'm writing like the square root in these parentheses. I notice that my last term is a perfect square as well. It's 5 squared, right? Now the question would be, if I took those two and I multiplied them and I doubled it, would I get that middle term? So if I do 2 times 5 times x, do I in fact get 10x? And I do, right? Okay, and the way that I'm going to get this negative, you'll see, is that I have to have a negative sign. So this qualifies if my first term's a perfect square, my last term's a perfect square, and then I take those two square roots, multiply them together, and double it, and I get that middle term, then this qualifies as a perfect square trinomial. When you factor a perfect square trinomial, you're going to get a binomial squared. So you're going to end up with a binomial that you're going to square. That first term, you take the square root of it, that's going to be your first term in the binomial. That last term, you take the square root of it, that's going to be your last term in the binomial. And you get your sign from whatever sign is right here. Now, what the heck have I just done? And let me prove to you that it actually works. Oh, before I do that, this is called the square of a binomial. Okay, so the result of factoring a perfect square trinomial is the square of a binomial. All right, so I'm going to prove to you that this actually works. I'm just going to go over here. I'm going to check it. You can do this every single time, and if you're not doing this, it's silly of you, especially on a test or a quiz, because you can make sure that you actually get this right. So if I take x minus 5 and multiply it by x minus 5, the question is, do I get what I originally started with, this trinomial right here? Let's see. So I'll just use the FOIL method or double distributing or whatever you want to call it. First terms give me x squared. Last terms give me negative 5x. Inner terms give me, or sorry, that was the outer terms. The inner terms give me negative 5x. And the last terms are giving me positive 25. So I get x squared minus 10x plus 25. Notice that my middle terms did not cancel out, okay, like they did here, right? My inners and outers actually just were exactly the same, so that's why that doubling works, okay? So that's a perfect square trinomial. Okay, so those are all the tricks I have up my sleeve. After that, your next friends you're not going to like that much. All right, so friend number 4. This is factoring ax squared plus bx plus c, or as I like to call it, guess and check. Okay, so sometimes I'm going to talk about a when a is 1, and then I'll talk about a when a is something other than 1, okay? So let's start with our first case of this. Let's see, I'll put a bullet mark. Okay, so this is when a equals 1. Now this is the easy one, okay? So when a equals 1, what you're going to do is look for factors of c whose sum is b. Okay. So for example, let's factor, how about x squared minus 2x minus 48. So some of you guys would use a diamond for this, and that's totally acceptable. So basically what you're doing is you're saying, what are factors of 48? That'll give me 2. Okay, so what are factors of 48? Factors of 48 Well, that's when I come over here to the side and I list them all. So we've got, let's see, 1 and 48, 2 and 24, 3 and 16, 4 and 12, 6 and 8. I think I got them all. Okay. And so now what you're going to look for is you're going to look for these two numbers. Now you can either add or subtract them because one of them could potentially be negative. And as a matter of fact, in order for your last two terms, okay, so the last terms in that FOIL, in order for the last terms to multiply and give you a negative, that means that one of them has to be negative and one of them has to be positive, right? So what am I talking about? You have two binomials that you're going to factor this into. Well, think about these last two terms right here. When you do that last multiplication, in order for you to get a negative 48, one of these will have to be positive and one of them will have to be negative. Right? So whatever these are, let's call them A and B right now. When I multiply A times B, I have to get a negative 48. Okay, so right now I'm looking for A and B. Okay. So we know one's going to be positive, one's going to be negative. So let's look over here. So if I add 48 and 1, I get 49. If I subtract it, I get 47. Not going to work. If I add 2 and 24, I get 26. If I subtract it, I get 22. Not going to work. Add those, I get 19. Subtract them, I get 13. I'm looking for negative 2 here, okay? I'm looking for 2. Not going to work. 4 and 12, 16 or 8, not going to work. 6 and 8, I'm either going to get 14 or 2. There's my two factors. 6 and 8. And I want to end up with a negative 2. So which one needs to be negative? The 8 needs to be negative, okay? So I guess this should have been negative 2. Okay. So I'm going to break this up into two binomials. Now, it's important to realize that the first term here comes from your first two terms in that FOIL sequence, right? So those first two terms should just be x and x, because when I multiply them, I need an x squared. My last two terms are going to give me that negative 48. We already established that they were going to be 6 and 8. Now, I think it should be a negative 8. So I'm going to go ahead and put negative and positive. And how can I double check this? Well, the first thing I always do is I go to my inners and my outers. I go inners, give me 6x, outers, give me negative 8x. Am I getting negative 2x as my total? I am. Then, quickly in my head, I say, well, and is x times x, x squared? It is. And how about my last terms? Does that give me negative 48? It sure does. Okay, so I have checked this. This is all me checking. The real answer right here is this. Okay, so the next type here of guess and check is when A is something other than 1. Okay, it doesn't equal 1, but it also doesn't equal 0, because if A equaled 0, we wouldn't have a quadratic. Okay, we wouldn't have an x squared. Okay, so A is some other number besides 1 or 0. Okay, so let's see what we can do about this. So now what we're going to do is we're going to find factors of A and C. Maybe I shouldn't put an and like that. I should probably write out and, so that way you guys don't think I'm putting addition. A and C, whose sum is B. Okay. Now I know that some of you guys may have learned this. You may know an algorithm for this, and you can go ahead and try and use that algorithm. I am not going to teach that algorithm because I would rather you just know where everything comes from, okay? So we're going to do a couple of these together, okay? So the first one, let's see. Let's do the first example. We'll do 2x squared plus x minus 3. Okay, so I am looking for factors of 2 and factors of 3 that when I do my inners and my outers, right, this inner and outer piece, I am going to end up with 1. Okay, so let's start with writing down factors of 2 and writing down factors of 3. I'm starting with an easy one on purpose. So this is 2 and 1, 3 and 1. I have no other options, right? Okay. So when I factor this into 2 binomials, I'm going to take my factors of 2. Those need to multiply to give me my first terms. So 2 and 1 come from my first terms. Okay, so this is a 2x and a 1x, or just x, because when I multiply those, I need to get 2x squared. Okay, now I have to figure out where to put the 3. So I can put the 3 here, and I can put the 1 here. Okay, and when I do that, and I'm just going to look at my inners and my outers, I get 1x, and I get 6x. So when I add this together, I'm either going to get 7x, if they're both positive, or as I can tell right here, this is a negative, right? Which tells me my last terms multiplying together, one has to be positive, one has to be negative. So that would mean that one of these would be negative. Well, if I take the difference of these, I'm going to get 5. Does that give me my middle term? My middle term is a 1x. Am I going to get 1x if I add or subtract these? No. So that's not working out. That's where I'm going to switch these around. And some of you may have already saw, well, hey, if I do 2 times 1, right? So if I do those, okay, as maybe my outers, as I have them written here, okay, and then I do these as my inners, that's a 2 and a 3. I can definitely get a 1 out of that. Okay. So the inners will now give me 3x. The outers will now give me 2x. I need to get a positive 1. So which of these two needs to be negative? The 2x should be negative, so that when I add them together, I get a positive 1x. So that means that when I multiply my outers, it needs to give me negative. So that sign, that negative sign, is going to go right here. This will be positive. And if you don't believe me, double check it again, right? So, I mean, just keep checking. There's no reason to miss these, because you can sit there and redistribute all day long and make sure that you got the right answer. Okay, so in the middle here, my inners give me 3x. My outers give me negative 2x. I've got the positive 1. Now let's check our first and our last. Checking the first, I get 2x squared. Perfect. And checking my last, I get negative 3. Perfect. Okay, so when I have factored this, it looks just like this. All right, let's try another one. We'll make these harder as it goes on. Okay, so next example, same directions. We're just going to factor this. So we're going to have 14x squared plus 2x minus 12. All right, so let's not forget any of the rest of our friends. Remember our first friend? Greatest common monomial? I need some help. I see a greatest common monomial in here. Okay, so I'm going to take the greatest common factor here and pull that out, or reverse distributive property it. So I'm going to pull out a 2. So it looks like I'm left with a 7x squared plus x minus 6. Okay, so the 2 just gets ignored. That's going to be part of the answer, but you're not going to touch that anymore. By pulling out the greatest common monomial, we were able to simplify or make our numbers a little bit easier to work with. So instead of looking at factors of 14 and 12, which both of these have quite a few factors, I'm now looking at 7 and 6. Well, 7's prime, so I'm looking at less factors. All right, so let's look at factors of 7 and factors of 6. So factors of 7 are 1 and 7. Factors of 6 are 2 and 3, 6 and 1. And I'm going to break this up into 2 binomials because I've got a trinomial. It's not a difference of 2 squares because it's not a binomial. All right, so first of all, there is no doubt in my mind that my first 2 terms here have to be 1 and 7. right? Because my first two terms have to multiply to give me 7x squared. So I'm going to have a 7x and an x. Now my second terms are going to be my factors of 6. So the question is, if I take these, let's say for example I do 7 times 2. Well, that's going to be 14. And then 1 times 3. That's going to be 3. So that's either going to give me 17 or 11. Not what I'm looking for, right? What if I switch it around? So instead, let's say I do 1 and 2 and 7 and 3. So that'll give me 3. Nope, sorry, I lied. That'll give me 2 and 21. Any way I can get 1 out of that? No. All right, so 2 and 3 must not be the factors of 6 that I meant to use. I'm going to cross those off. How about 6 and 1? Any way to use 6 and 1 with 7 and 1 to just get 1? So I think this is a lot like our last problem, right? We know that we want to have, our inners and our outers adding up to a positive 1x. Well, I think that if I multiplied my inners and I got 6x, and my outers where I got 7x, and I made one of these negative, then I could definitely get 1x. And again, I knew it was going to be negative because of this negative sign right here, right? My last two terms have to multiply to give me negative 6. And I want the 6x to be negative, so the negative sign goes in the first binomial. I have completely factored that one. All right, let's do one more. How about we do a 4x squared minus 4x minus 3. So no greatest common monomial to help me. Not a difference of two squares. Not a perfect square trinomial. That's not a perfect square. Okay, so it's my guess and check method. And I have an A. That's something other than 1. So I'm going to go straight to looking for factors of 4 and factors of 3, where my inners and my outers will end up giving me that negative 4x. So factors of 4 are 4 and 1 and 2 and 2. Factors of 3 are 3 and 1, and that's it. Okay? So I want to end up with 4x in the middle. So let's see. I can do a combination here of like 1 and 3, which would give me 3, and 4 and 1, which would give me 4. So is there any way to do 4 minus 3 to get 4? No. 4 plus 3 to get 4? No. Okay, so those cannot work together. And even if I switch them around, so maybe I do a 4 times 3, which is 12, and a 1 times 1, which is 1, is that going to give me 4? No, that's either going to give me 13 or 11. So I know that 4 times 1 cannot be one of my factors. Okay, so let's use the 2's. Okay, so let's look at this. So if I do 2 times 3, I'm going to get 6, and 2 times 1, I'm going to get 2. Any way to get 4 out of that? Yeah, if I subtract them. And does one of them have to be negative? In fact, it does, because my last term is negative. Okay, so I know I'm going to use 2 and 2 as my factors of 4. So that's 2x and 2x, because if I multiply them again, my first terms need to give me 4x squared. Now, it doesn't really matter where I put the 3 and the 1, because both of my first terms are exactly the same. So I'll put 3 and 1. But the key will be which one should be negative. So again, my inners give me 6x. My outers give me 2x. I need a negative 4, so that means that the negative needs to be with the 6 to give me negative 4x. And I'll get that when the 3 and the 2 get multiplied together. So I'm going to put the negative in the first binomial, positive here. I know that these are challenging. Please, please, please get your repetitions. Watch this video over and over and over if you have to. I have one more factoring friend for you. And it's my favorite one because it's so obvious. And it is called, so let's see, it's number 5. It's your last friend. This is all you get, 5 friends. Oh, and they can't all help you, and sometimes they don't all want to help you either. All right, so this one's going to be factoring by grouping. This one's always going to have more than 3 terms. So it's going to usually have 4 terms. Okay, the example I'm going to do is 150 m squared nz plus 20 m, then n squared, then c, minus 120 m squared nc minus 25 m n squared, and then z. So I know I'm using a lot of variables here. And I'm doing a challenging one so that way we've done probably one of the most challenging ones, so it'll only get easier from there. So again, I always go to my very first friend. First friend, greatest common monomial, can you help me out? Is there a greatest common monomial in all of these 4 terms? In fact, there is. They all have a 5 in common, so I'm going to pull out a 5. They all also have an m. This one has an m squared, m squared, m. Okay, so I'm also going to pull out an m. Okay, and they all also have an n squared, n squared. So I'm also going to pull out an n. Okay, so what's left here? Well, 5mn times what gives me this first term? 30mz. And 5mn times what will give me the second term? It's going to be 4nc. And 5mn times what will give me this third term? There's going to be a negative 24, because 5 times 24 is 120. I need an m. I don't need an n, but I need a c. And 5mn times what will give me the last term? Well, I'm going to need a 5. I've already got an m. Okay, I'm going to need another n and a z. Okay, so this is where the grouping comes into play now. Now that I've gotten, and I could have done, I could have gone straight to grouping here, but it's just easier to just work with these numbers and leave this outside, which is exactly what I'm going to do. I'm going to leave the 5mn outside. And as I continue to factor this, I'll put that into brackets, okay? So what I'm going to do here is I'm going to group my terms. I am looking for terms that have common factors, okay? So, for example, I see that 30 and 24 would both have a 6, and they both have an m as well. Okay, so I am going to use 30 and negative 24. I'm actually going to group those, so I'm going to write those closer to each other. And then I'm also going to group the 4nc and the 5nz, because I can see that they both have an n in common. Okay, now I'm going to write this one first because I want to give you an example where negative is in this position. So negative 5nz and a positive 4nc. Okay, so within this bracket now, I need to group my like terms. And the way I show that is by putting parentheses around them. Now I'm going to keep this sign with this second group, and I'm going to turn this positive. That's going to be the easiest way to work with these negatives. Okay, so if you have a negative in one of your groups, just group it with the group and make it positive. Okay, got to put a plus sign here though, otherwise you're going to think you're multiplying things together. Okay, so my goal now is to look at each of these groups and factor out in each of these groups what they have in common in each group. Okay, so I'm going to keep my 5mn outside. Keep my brackets. Now looking at my first group, what do they have in common? They have a 6m in common. That's what I'm factoring out. So what's left? Well, 6m times 5z will give me that first term. And 6m times a negative 4c will give me that second term. Now in this second group, what's my greatest common factor? It was an n. And here's where I'm going to pull out that negative factor. Because what I'm doing is when I have this, whatever I pull out of here, I want to end up with the exact same factor as what's right here. And I can see that coming pretty darn close. The only thing would be that this negative sign needs to be there. So if I pull out the negative, that'll make this a positive term and that a negative. So I'm going to pull out a negative n. And what's left is 5z minus, and it's going to be a 4c. And this has worked out perfectly for me because notice these two terms are exactly the same, or these two factors, right? So I have two terms here. One term is here, and one term is here. And of those two terms, they have a common factor, 5z minus 4c. So I'm going to pull out a 5mn, or that, I'm sorry, that was already pulled out. Now, in here, I'm going to pull out that greatest common factor, 5z minus 4c. And then I'm going to write whatever's left. So 5z minus 4c times what will give me this first term? Well, it's going to have to be 6m, right? And 5z minus 4c times what will give me the second term? It's got to be that negative n. Okay, so at that point, I could leave it looking like that, or you might also see it like this. You don't really need these brackets here anymore. Because multiplication is commutative, you could do it in whatever order you want. Okay? But a lot of you guys might prefer if you were going to multiply this back out to check, starting here, do your FOIL, then distribute the 5mn.